going to do 1 over x squared for our library of functions. And if you watch 1 over x, and you should watch the graphing of 1 over x movie before you watch this one, because we're going to abbreviate this slightly, because it has a lot of the same features as 1 over x. What happens here, obviously, when I put 1 into here, I'm going to get 1 over 1 squared, so I'll get 1. And then I'm going to get 1 over 2 squared, which is 1/4, 1 over 3 squared, which is 1/9, 1 over 4 squared, which is 1/16. So if I put these numbers into here, and I do exactly what it tells me to do, square them on the bottom, I get these numbers, which is very similar behavior to 1 over x. Now, if I put in 1 over 1 over 2 squared, I'm going to get 1 over 1 over 4, which equals 4. So I'm going to get 4 here. If I put 1 over 1 over 3 squared, I'm going to get 9 squared, sorry. And in this case, I'm going to get 16. Okay? 1 over 1 over 4, quantity 4 squared, that's 1 over 1 over 16, which gives me 16. So the behavior is, as I move out to the right, it gets smaller and smaller. So if I'm over here and I got 1, I'm going to have, let me make that a little better, I'm going to have 1/4. As I go to 2, I'm sorry, 1 is 1. I almost put the wrong point in there. 1 is 1. 1 and 1 is a point, but 2 and 1/4, it drops quite a bit. 3 and 1/9, 4 and 1/16. It's still, just like 1 over x, it's getting closer and closer to the x-axis, but it's never going to touch it. It'll just get closer and closer, and that's called being asymptotic to the x-axis. Also notice this, when I put in 1/2, it starts to grow. 1/2, it goes up 1, 2, 3, 4. If I put in 1/3, I'm going to go all the way up to 9. And then 1/4, I'm going up to 16. So it behaves exactly, it looks a lot like 1 over x at this point. Okay? This graph looks, except that it is growing faster as I approach 0, and it's sinking faster. So in that way, it's not the same as 1 over x exactly. Another interesting feature is that, notice, this is squared, so when I start doing it on the other side, it's going to square the negative numbers, and I'm going to get the same thing on the other side. Just like that. This is an even function. If I call this f of x equals 1 over x squared, and I looked at f of negative x, I would end up with 1 over negative x squared, which equals 1 over x. So I squared, excuse me. So if I put in the negative x, I end up right back of f of x, which means it's an even function. That means it reflects across the y-axis. And I advise you to go to your calculator, pop that in, and see if that isn't true. See if it doesn't look like that.